Next up on the agenda, we have a keynote talk, and I'm very happy to welcome together with you Londa Schiebinger, who is a professor at Stanford University and director of the joint EU and US project Gendered Innovations in Science, Health, Medicine, Engineering, and Environment. Londa is really the world-leading expert on sex and gender analysis in science and technology. So I'm really very excited to have you here giving a keynote talk to us. Thank you.
It's a pleasure to be here today. And I really thank you for bringing us to this beautiful university. This room is so very beautiful and looks comfortable for the entire day. So today we're going to explore gendered innovation. So I want to give a general background for sex and gender analysis. We're going to explore gendered innovations. And Gendered Innovations was produced through a large international collaboration involving the European Commission, the US National Science Foundation, and Stanford University. And the project is now expanding into South Korea, South Africa, and we're sort of tiptoeing into Japan, which has a very traditional gender culture, but nonetheless, I'm going there in June, and we're taking our second and third steps toward seeing how they will integrate sex and gender into research. New policies have been implemented in the European Union, Canada, and the United States, and we're expanding into Silicon Valley. Of course, Stanford is only about 20 minutes from Google, but there can be a vast gulf between cultures. Innovation is about integrating sex and gender analysis into the design of research. The operative question is, can we harness the creative power of sex and gender analysis for discovery? Does considering gender add a valuable dimension to research? Does it take research in new directions? So it may not just be that the Human Brain Project wants to look at, wants to analyze gender in how they're currently approaching the brain. There may be new directions in research that really taking gender seriously will open up. Before I start, I want to give a bit of background. Governments and universities in the United States and Western Europe have taken 3 strategic approaches to gender equality over the past several decades. The first is fix the numbers of women, and this focuses on increasing the numbers of women, giving chances to young women in science, so having diversity on the team. The second is fix the institutions, which promotes gender equality in careers through structural change in research organizations. And the third, fix the knowledge, or gendered innovation, stimulates excellence in science and technology by integrating sex and gender into research. Now, I like to analyze these three approaches, but of course we know these approaches intersect. We just had a paper in Nature Human Behavior which showed a link between my number 1 and number 3, so fixing the knowledge and bringing more women into science. People usually think you fix the numbers of women first and then you think about the knowledge, but we found that also the reverse may be true. We found that if there are more women on the research team in the position of first and last author, that articles, this is in medical research, articles were more likely to incorporate sex and gender analysis. Or it could be vice versa, that if you use diverse methodology, you suck in the women. So it could be that including gender analysis into research pulls women into research careers. For policymakers, our findings demonstrate an important empirical link between increasing the numbers of women in academic medicine and enhancing excellence in research by incorporating sex and gender analysis. So my short talk this morning will focus on this third strategic approach, fixing the knowledge. It's the newest area and the most important for the future of science, engineering, and innovation, and it's what Gendered Innovations is all about. Doing research wrong costs lives and money, so I'm very glad that the Human Brain Project is incorporating sex and gender analysis from the very beginning. we have this important statistic here that between 1997 and 2000, 10 drugs were withdrawn from the US market because of life-threatening health effects, and 8 of those showed greater severity for women. Not only did these drugs cost billions of dollars to develop, but when they fail, they cause death and human suffering. We can't afford to get the research wrong. But doing research right can save lives and money, and I hope this will be the case for the Human Brain Project. This is an analysis of a large government research project done in the US in the 1990s called the Women's Health Initiative Hormone Therapy Trial. And this trial was looking at the question of whether or not women should take estrogen supplements after menopause. So that was the question. But doing the research right can save lives and money. We found the public health economists who did this found that for every dollar spent in the project, 140 were returned to the US taxpayer in healthcare savings. And doing research right also saved lives. There were fewer cases of cardiovascular disease, fewer breast cancers, and more quality-adjusted life years. The downside of women not taking estrogens was that there were more osteoporotic fractures. I really like these kinds of metrics. I don't know if it would be appropriate in the Human Brain Project to set up some kind of metrics that you will have at the end so that you can evaluate these sorts of things. So it's crucial to get the research right from the very beginning, and this is the goal of the Gendered Innovations Project. This project develops state-of-the-art methods for sex and gender analysis and provides case studies or concrete examples of how gender analysis leads to discovery and innovation. And in this talk, I'll discuss a few of those case studies with you. But first, let's make sure we're all on the same page. I want to look at, let's see, what did I do with my pointer? Here we are. Okay, so this is an image from Vera Rogitza-Grosek, who is one of your powerhouses of gender medicine here in Europe. And this slide simply shows that human beings, or our human brain, is composed of sex elements, genes, hormones, and the like, and also gender elements or social or environmental elements. Nutrition, she's emphasizing nutrition and lifestyle, but I think for the human brain, education would be important, social experience, the experience of discrimination or not discrimination, gender bias in the culture or gender equality in the culture, and all of these social gender experiences interact over the course of a lifetime to give you the outcome, the human brain at present. So sex can influence health, is what Vera's point is here, by modifying behavior, and gender behaviors interact with and can influence biology. This is why we care. So gender behaviors can modify biological factors. For example, we know that exercise can strengthen bones, or we know that social discrimination can lead to stress, which in turn impacts health. If we think about the brain, the one thing that has been shown is there's this difference between men and women in spatial relations, and we know that if girls have more training, they quickly catch up. So obviously, the experience there can shape people's abilities. Now, just a little bit more background. We know that the human population, these are statistics for the US, the human population divides by about 51% female at birth, 49% male at birth. Then we have people who are intersex, so ambiguous by sex, if you want to use those categories at birth. The measures here are really, really horrible, so you see that it can be between 0.06 to 1.7%. Statistics are not kept when people are born, so we don't have very good measures. Transgender in the US is 0.6%, which ends up being nearly 2 million people. It's becoming to be a large population. And gender fluid, depending on what we mean by that, is unknown. We don't have measures of that. So I think, interestingly, intersex There are 8 countries that allow you to choose intersex on your birth certificate. The US, we don't have a 3rd category on the birth certificate. Do you know what the 8 countries are? Germany, right? Germany, but it's only 3 months. You only have this choice for 3 months, which I think means that the doctors, in the US, people argue that the person who is intersex should have the choice of whatever they want to be in the future, which could be neither male or female, neither men or women. But the other countries are something of a surprise to me: Bangladesh, Australia, India, Malta, Nepal, New Zealand, and Pakistan. Who knew? So now let's get on with our business here. Let's go back to our... Yeah. No, I mean gender. I don't mean sex fluid. I mean gender fluid. And I think it's a question right now what we mean by that. You have to remember that gender is about gender norms, gender identity, and gender relations. So I think what we want is gender fluidity and gender norms. People seem to think of, so norms are, social norms that force us into certain behaviors. People seem to think about gender fluidity having to do with identity, which means that you don't really take on the behavior of a man or a woman. I mean, I would say that I'm gender fluid because I'm masculine at work. To be a Stanford professor, you gotta take charge, and we associate that with masculinity, but hopefully at home, now my children would probably tell me I'm also masculine at home, but I mean, hopefully at home I'm a little bit softer, and I think men also have these experiences. We change our behaviors according to the norms of the situation. So my goal would be gender fluidity of norms, and I think people are only thinking of it right now as gender fluidity in identity. So let's loosen up the norms. So there you go. Okay, let's go back to why these 10 drugs were withdrawn from the US market. There are many reasons why drugs fail, and fail more often for women, and one reason is that most research is done in males, whether human, animals, or cells and tissues. This study was done in 2011 by some colleagues at Berkeley, and it's showing the sex of the animal in laboratories, used in laboratories. So you see the blue that mostly male animals are used, except in the area of reproduction and immunology. But what I'm interested in is the gray area here, where the sex of the animal is not recorded. That is when you cannot do proper science, if you cannot look at sex differences between your subjects. So this is really just money wasted. You might as well throw it out the window. Certainly the European Commission should not fund projects that do not say what the sex of their animal is. This study was done also in 2011 on cells and tissues. This was done at Mayo Clinic, and here you can see only gray area. The sex of the cell is almost never recorded, and again, this is money wasted. Okay, you're thinking that was 2011, it's a really long time ago. Okay, so here is a study that ends in 2014, and now they're using the NIH language of sex considered as a biological variable, and it's just flat, nothing has changed. So the sex of the animals is still often not considered. We expect now to have a large bump up here because the European Commission has had this policy to analyze sex and gender since at least 2014, if not before. And the US National Institutes of Health just put a policy in place in 2016 that anyone applying for public funded research, that's all of our national funding, must look at the sex of the subject. Cells, animals, and human beings. They aren't doing gender yet. We're working at Stanford on an instrument to measure gender, which is a very long story, but I think that when we have proper instruments for integrating gender into, say, clinical trials, then we'll be able to do more of that. And I hope NIH will expand its policy to match more the European Commission's policy. Now I want to go to the website, and I want to look at some case studies. And here we have all of our methods loaded up. It's 12 methods, which are the questions that researchers can put to a project as they begin their research to see that they are integrating sex and gender well into their project. Then and I'm not going to talk about the methods today, then we have our case studies or our examples of sex and gender analysis in 3 buckets: science, health and medicine, engineering, and environment. And I'm going to talk about a couple of these case studies today, and I'll start with stem cell research. And of course, this is all publicly available. The site is mirrored on the European Commission site so that Stanford and European Commission have the same site going. So let's look at stem cells. Why might the sex of the cell be relevant? You saw in my earlier slide that people almost never look at the sex of the cell, but we see that the sex of the cell can be relevant. Research shows that there are sex differences in the therapeutic capacity of stem cells. This slide shows here, this is from muscle tissue. So the female stem cell is more regenerative or active than the male stem cell. Yet very few researchers consider the sex of the cell, which can lead to failed research. An international team from Norway and Australia worked with stem cells in mice, and in this study they appropriately used male and female mice. So they get a good grade on that part of their research design, but they used only female stem cells, and this was an unconscious and arbitrary decision. It means that in the discovery phase, they did not see anything unique to the male stem cells, nor did they detect important differences in function between the male and female cells. The result of not considering the sex of the stem cell was that their male mice died, and they didn't know why. This means that they set the project on the shelf. They didn't know how to go forward, so this is money wasted. So they thought maybe a postdoc made a mistake, but that didn't really help them. So they found, eventually, that, let me see, how can I scroll down here? Here we go. They found eventually that after a gendered innovations workshop in Norway, they realized, oh, we should look also at the sex of the cell. And they found that in their case, in their research, the matching of male to male and female to female was the best combination. But of course, research isn't always that easy. We have a foundational method, which I won't take the time to look at right now, called analyzing factors intersecting with sex. And in the case of stem cells, these factors might include the cell type, the disease being treated, or other variables, hormonal, immunological, or environmental. Now, let me just interject here that what is true for matching of cells and animals in research may also be true for human organ transplant. I hope none of you ever need a heart transplant, but we know that for heart transplants, the same is true, that sex matching gives you the best outcome. The same is true for kidneys. Lungs don't follow that pattern, so in every instance you have to do the research. You can't assume anything. So that's the science of the sex of human organ transplant. But now we have a gender problem, and that is that in US society, I'm not sure what is true here in Europe, women donate more organs. So even if the surgeon knows the best science for a transplant, there might not be the right organ available. So both have to be considered always, the sex and the gender, in any kind of research. So far, I've been talking about analyzing sex, and the example I gave was about stem cells. Now I want to open the discussion to gender, in a way. You might object, but anyway, environmental factors, and I want to look at animal research. So in the same way that we had Vera's slide up there, that there's an interaction between the biology and the environment, you see in animal research, this is like a laboratory. And in animal research, there's an interaction between the biology of the animal and the laboratory conditions. It can be differences in caging, and these environmental, sometimes they're based on gender differences, interact to give you an outcome for the animal. So the example, quick example I'm going to give is the research staff. But any number of environmental factors in the laboratory can impact the biology of the animal. And now, since the NIH has this requirement that researchers look at sex differences in animals, in addition to humans and cells and tissues, I'm very concerned that we don't overemphasize sex differences, or we don't find sex differences when we're really looking at a social or an environmental condition. So that's what this story is pointing out. So this is an important study from Sorg et al. It's a laboratory at McGill University in Canada, and the example focuses on pain research. The researchers induce pain in rats and mice, and what they found is amazing. They found that rats and mice don't show their pain to men in the room, to male researchers. This is really important because the researchers are studying sex difference in pain response, but the animal doesn't show their pain if a man is in the room as compared to an empty room, or if a woman is in the room. So they tried, to be scientific, they tried all sorts of conditions. They put a chair in the room. Was it just something in the room? They put a cardboard image of a human being in the room. Was it something looking human in the room? But they found that it was men in the room. The researchers identify this as the male observer effect. So you've probably already figured out what's going on. It's not how the researcher acts or handles the animal, though sometimes that is an important factor. What is it? The animals smell the men. They smell the male pheromones. So according to Jeff Mogul, whose lab this comes out of, this phenomenon may throw into question all prior research results on pain. Now, there's much I could say about biomedical research, but I want to now move on to machine learning, because machine learning is very important in many of the sciences and also in medical research. And I'm going to start with an example from natural language processing. And here I go to our engineering portal and use machine translation. And I think these examples are very important for brain research because it shows you the kind of unconscious gender bias that is in our culture, that is all around us. We at Stanford are now founding a human-centered artificial intelligence institute. It's new, we're just beginning to find it. And I hope that artificial intelligence will have less gender bias than the human brain, I guess we could say. All right, so I start with a story. Some years ago, I was in Madrid and interviewed by some Spanish newspapers. I don't read Spanish, so when I returned home, I put the articles through Google Translate, and I was shocked that I was referred to as he. Londa Schiebinger, he said, he wrote, and sometimes it thought. Google Translate has a male default, a masculine default. So I was confused. How can such a cool company as Google make such a fundamental error? Google Translate defaults to the masculine pronoun because he said is more often, it's in the database. He said is more often in the database than she said. And we all think of algorithms as neutral, value neutral. So where exactly is the gender bias in this system that Google developed? So Google Translate defaults to the masculine pronoun because he said appears on the World Wide Web 4 times more often than she said. The peak of that ratio was 1968, 4-1, and it dropped dramatically through until 2010 to 2-1. So right now it's about 2-1. And what else happened? So we had a huge cultural revolution in this period. We had the women's movement. We had the US government invested a lot of money in increasing the number of women in science and engineering. We had the birth control pill was developed. All of the English language included inclusive language, he and she. With one algorithm, Google wiped out 40 years of cultural change. So the fix, a couple years ago, Gendered Innovation held a workshop. We invited Google to a workshop, and we invited one of our natural language processing experts from Stanford. They listened for about 20 minutes, and they got it, and they said, oh, we can fix that. I mean, Google was amazed. They had no idea this was going on, and they didn't want it to be going on. So again, some products can be fixed, but constantly retrofitting for women is not the best road forward. I had to ask myself, how is it that the Google engineers, many of whom are educated at Stanford, made such a simple mistake? What are we at Stanford doing wrong? Well, for one thing, students at Stanford can take a lot of cool gender courses from me over in history of science. But we do not have gender courses where they live in engineering. So we are now working on integrating basic gender issues into basic engineering courses and basic computer science courses. This is something that universities need to do. So again, some products can be fixed, but what if Apple, Google, and other companies started product development research by incorporating gender analysis? What innovative new technologies, softwares, and systems could be conceived? The point I want to make is that this unconscious gender bias from the past amplifies, increases gender equality in the future. When trained on historical data, as Google Translate is, the system inherits bias, including gender bias. It turns out that even though Google wanted to fix the problem, they've been unable to. If you put the same text through Google Translate, you get the same results today. It's sometimes harder to fix something once your basic platform is set. And this is why we insist that research start from the very beginning to include both men and women, both sex and gender, so that you get the kind of outcomes you want. So, in other words, past bias is often perpetuated even when governments, universities, and companies themselves, like Google, have implemented policies to foster equality. So the big question is, how can humans intervene in automated processes to create the society we want? Now, it's not just Google Translate, but I want to point out that this has become an important problem now in computer science, and we find many instances of this same kind of gender bias unconsciously perpetuated through automated systems, through algorithms. So Google search, for instance, men are 5 times more likely than women to be offered ads for high-paying executive jobs. Why? The machine understands very much that women are paid less than men. Here's an interesting one. There's a technique called word embedding, and it can see the associations between words, and it sees that if we don't intervene, that these historical stereotypes will be returned to users. So on the web, there's a close relationship between the word man and computer programmer, and a close relationship between the word woman and the word homemaker. Another example, and this is an interesting one, search image, or image search. So stereotypes about men's and women's occupations are often exaggerated in image search results. If you search for the word nurse, you get pictures of women, right? And the search misses the 10% of men who are nurses in the United States. So again, it's reinforcing stereotypes through automated systems which are picking up the gender bias in human society. Now, if we fix this algorithm, do we want the image search to return 50% images of men? Do we want the image search to be aspirational or to reflect reality which is not yet gender equal? So the kinds of solutions, there are many, many solutions being offered. These have to be interdisciplinary. It's teams of computer scientists, lawyers, political scientists, historians, and especially gender experts who are now attempting to optimize algorithms that guarantee fairness. In 2 weeks, we're doing a workshop at Stanford on fairness and gender in machine learning. We want to identify exactly where in the machine learning process the bias resides. We want to, importantly, we want to map the solutions that are being developed, and then we want to discuss who should be involved in the decisions about how to fix these problems. And I think this is an important issue. Should it be the computer scientists themselves? If so, we need to change computer science education so that these computer scientists would understand human society, computer science, and ethical approaches and gender. Should it be ethics teams? I think that's too late. That's usually after the fact. And government oversight committees is no one's choice. We're also doing, you know, robotics. The robots are coming. I don't have time to go into that right now. But we're also doing, or we did in January, a workshop on gender and robotics, so artificial intelligence and the embodiment of that. It's very interesting. Why do people feel the need to attribute gender to robots? Is gender domain specific? Is a woman's voice, so often if you look at dating apps, it's a woman's voice, whereas math tutoring apps will be a man's voice. What kinds of things gender a robot? After all, it's a machine. And then we want to see what is the appropriate kind of social touch between robots and humans in relation to the gender of the person vis-a-vis what might be called the gender of the robot. And then, of course, research shows that humans often harass robots. And in any case, we want to develop a virtuous circle of gender influence between robots and humans so that we can promote gender equality in human society. Okay, so I could give many examples. We have 26 case studies on our website, but I hope that you will see that looking at gender is one very important part of world-class science and technology. So I'm very pleased, Katrine, that you said about the human brain that we don't want to find female brains and male brains. That would be a mistake, and you were emphasizing the overlap between brains and the great variability, individual variability. So we really, really need to look at sex and gender in the human brain, but we need to do it correctly. So I had a little finish. I should finish up now? I wanted to go into some policy stuff, but I think we should move on. Okay. Good.
Maybe we have the time to take 1 or 2 questions.
Oh, sure, yes, of course. I run a listserv, and if you want to be up to date on new things happening in sex and gender analysis in research only, I don't circulate anything about participation or climate change or any of those issues because I think they're well covered. So only about gender in research, you can sign up. I don't send anything more than once a month. And it's only me that sends out things, only me. So you don't get much. But I try to, hit the important things that are coming out. Any 1 or 2 questions?
Any questions? Oh,
we will have time in the session later to have questions as well.
Good morning. Thank you so much for your presentation. I would just would like you to comment a little bit more on what you mentioned of do we want aspirational representation or the real that currently is still unbalanced. So could you comment a little bit more on that, please?
Well, I think that's an open question. Now we're going. So the great promise of algorithms was that they were completely value neutral, right? They were objective. That was the great promise of these automated systems. And now we realize that we have to intervene because we're simply reinforcing all the bias. I didn't give you the ones for the court systems, the examples of the court systems in the US, which discriminate against African American populations. So very serious stuff. So I don't know. It's an open question. Do you want the algorithm to simply reflect reality so we know what's going on? So if you search the word or take CEO, if you search the word CEO, you get many, many pictures of men, and it misses the small percentage of women who are CEOs. Do we want that so that women will still come to a site and see CEOs and mostly not see themselves? Or do we want to use these kinds of algorithms as an intervention system where we suggest what equality looks like? I really don't know. I don't know. I mean, I'm posing the question, so we would want to think about it much more. But I do think I think we need to start being aspirational. We need to. I know all of you are aware that the movies in the U.S. are changing at last. Finally, we're getting some movies with women in heroic roles, although they're often just men shooting guns, and that doesn't really help. We want to change it. But so I do think that all the images and the representations we see in the movies we watch and the way newspaper articles are written and the subjects they choose to write about, all of this influences our behavior. So I'm not sure what the answer is. Yes.
Thank you very much for your presentation. And as in many other things, Stanford is doing a great job with this gender innovation program. You said that you had a few more slides about policy, which is precisely a question that I'd like to ask you about. So we're on the brink of many new types of technologies in terms of imaging or big data projects where we can integrate digital information from patient folders. What do you think are the best approaches in terms of policy so that gender is included in these new sorts of technology adventures right from the beginning, so we don't have to go through retrofitting in 20 more years? Exactly.
So the databases for health are not very good. We have a project, it's in the Public Health Research Center at Stanford, where we're taking all the health databases of the United States and reviewing them for sex and gender. So usually sex is in a health database. Are you male or female? I don't know if they ask about intersex or other.
But gender is usually not.
Gender is usually not, and we're really going to review them for gender. So that's in U.S. Medical data sets or health data sets. And then there's another group at Stanford headed up by Gary Darmstadt, and he's looking at the global data sets and the gender questions that are asked there. And to see what is asked, what isn't asked, he's found a lot of, for developing worlds, the kind of information, the kinds of questions are asked are biased in the first place, assuming that women are in the household and taking care of children. I mean, just these very basic things. So we're auditing everything, and then we're going to have big recommendations about what gender information should be collected. Are you working on that as well?
I'm very interested in working on that because I think it's something that we have to solve at this particular moment, because we are about to enter a huge new era for this sort of technology.
Absolutely.
And it would be an absolute pity not to have this information collected or not to be able to extract it from the existing data sets that we have, and to make recommendations for the American Medical Association, for the European Cardiovascular Society, or whatever, about tools that can be implemented at this particular moment.
Yes, absolutely. I would like to, maybe we can talk later to see all what's going on. We have these two initiatives, and we would love to join up with other initiatives as well.
Great.
I'll do it together. Okay.
Thank you.